Black box experiment. This is an experiment to identify the passive circuit elements and also determine their values. Passive circuit elements are the elements which works only when energized, such as resistor, inductor and capacitor. The basic idea behind this experiment is that the study of response of each passive circuit element with respect to applied AC frequency. We know that the capacitive reactance of a capacitor decreases with increase in applied frequency, whereas inductive reactance of the inductor increases as the applied frequency increases. But the response of resistor is independent for the applied frequency. So, this fact is used here to identify the passive circuit elements, and these circuit elements are connected in series so as to study the resonance frequency, and hence their values are determined using resonance condition. This is black box. All the elements, the passive circuit elements are enclosed inside the box. The element A, B, C, the terminals are kept open so as to connect in the circuit. Connect all these passive circuit elements in series with AC milliammeter and function generator. Connect the voltmeters across each element and refer it as the voltage 1, voltage 2 and voltage 3. Let me start. So, element A to element B to element C. The element C is connected to a milliammeter in series with an oscillator, and the other end of oscillator connected back to the element A. Now, all the circuit element, passive circuit elements are connected in series. Now, connect the voltmeters across each element. So, the voltage across element A is noted as V1. Voltage across the element B is noted as V2. The voltage across the element C is noted as V3. Now, set the frequency at 100 Hertz. Note the readings, the milliammeter as well as the voltmeters. Record it as V1, V2 and V3. Repeat in steps of 100 up to 900 Hertz. Tabulate the readings in the tabular column given, and you observe that as the frequency is increasing, the current through the circuit is also increasing. The voltage across the element A, element B and element C is noted, and their impedance values are evaluated, and it is observed that the impedance of the element 1 is remaining constant, which implies the element must be resistor. The impedance of the element B is observed to be decreasing, that implies the element, the passive element must be capacitor. And in the third case, the impedance value is increasing continuously as the frequency is increasing and observed to be an inductor in the circuit. Now plot the graph of the impedance values versus the frequency applied. You get a curve which is decreasing for the element B identified as capacitor, and the impedance value increasing continuously identified as inductor, and the other element, the impedance value remains constant identified as the resistor in the circuit. So note the impedance value corresponding to the resonant frequency of the circuit. So which is nothing but the intersection of these two curves where XL and XC meets. So XL is equal to XC will tell you that the corresponding resonant frequency, and note F naught and X value from the graph, and using the relation L is equal to X by 2 pi F naught determine the self inductance of the coil, and using the relation C is equal to 1 by 2 pi F naught X determine the capacitance of the capacitor used. So this is how we determine the values of the passive circuit elements by simple way of doing it. So element A is identified as resistor here, and its value is nearly equal to 1 kilohertz, 1 kilo ohms. Element B is identified as a capacitor whose value is around 0.1 microfarad. Element C is identified as inductor whose self inductance value is around 1 Henry. The possible viva questions related to this experiment are: